We stay at the topic of security, so now we got Dr. Johanna Ullrich, or Johanna Ullrich, depending if I want to pronounce it in any way. She's a senior researcher at SBA Research, and she wants to talk about data. Not necessarily in an AI fashion, but where do we get data from to do proper research in security? How can we trust that data, and how can we actually make assumptions from that data that make sense to train AI models with? But the first thing to do is, where do we get data from? So, give us all the lowdown and give us the data. Thank you.
Addiction to data is vital not only to artificial intelligence, but also to research, and in particular also to my field, which is security research. And comparable to an addiction, the need for data is increasing over time. So that might be the same as with alcohol or any kind of other drugs. So welcome to my talk. In the next couple of minutes, I will first explain and show you why I need data for my research. And second, I will explain the challenges that I have thereby, and maybe also some introduction on how we solve it. My name is Johanna Ullrich. I'm working for SBA Research as a senior researcher. I'm focusing there mainly on network security and cloud security. And I also have an interest in what is now called cyber-physical systems, so bringing security to some old traditionally engineered systems and keep them secure. I'm working for SBA Research, which is a research institute based here in Vienna. We're focusing solely on IT security, and our USP is more or less, or that's what we claim, we are the biggest research institute focusing solely on IT security in this country. But maybe you've already heard our politics. Austria is a small country, so we are the largest and the only one. This is our team, and part of us, including me, are doing offensive research. Offensive security research means basically we're hacking, we're trying to find new attacks, but instead of selling them on the black market, we go to the producers, tell them about the bugs, and hopefully they will fix them. The reason why we do is either we have some premises on moral or ethics, we prefer being free of a jail or have a family. So that are mainly the reasons why we do this. And the information that we need for evaluating our attacks are becoming more and more. And I want to tell this by looking back into history. And back then, when we developed attacks, it was fairly easy to test them or to evaluate them before going to the producers by using a test bed. I'm pretty sure that this is something that's also known to you as developers, or at least you should be aware to it. So we just set up a server or whatever that was equivalent to the original, and we tested the attacks against the server. And this was fairly straightforward and simple because we just needed the installation, and we could test it, and we didn't have any moral or legal problems. And if the attack was successful, we were successful as security researchers. This, however, has changed with the advent of large internet infrastructures, which are, for example, clouds. And the reason, therefore, is that such large internet infrastructures appear as a black box to the outside. So they appear as a black box to the customers, but they obviously appear also to attackers, and they also appear as a black box to us. So basically, what we see now, that we do not have enough information to plan an attack and to evaluate an attack and do our work. So we had to change our approach. One alternative would be attacking the clouds directly, which is not a good idea, and you will need a good lawyer if you do that, especially as the large cloud providers have typically more monetary money than we have. So that's not a good alternative. And second, we wouldn't have enough information about the internals of the cloud, so it wouldn't be feasible to develop an attack because you just don't know anything. So we need data. And while the information was in the old version already in the system, so basically we could look into the system and see what's there, we now have to find out in a first step what's in the cloud. And so researchers tended to adopt the idea of from cryptography, which are side channels, and use it for cloud computing. The idea thereby is that you measure something that is accessible to find something that's not accessible by you. So, for example, you can, in cryptography, typically measure, for example, electrical emissions or something like that, and you try to get the key, which shouldn't be accessible to you. And this was what was done in the first years of cloud computing, and the first researchers who did something like spying on the cloud used tools that are perfectly aware to all of you, like the ICMP protocol, so simply pinging to find the internal infrastructure of the cloud. So what happened in the next step was that large cloud providers and most of them simply disallowed the use of ICMP, and all the ICMP packets were filtered on somewhere on the way. So, and this is now where you need to find the information, but still you get it because you can use this kind of side channel. So, as ICMP is not allowed anymore, you just try to connect to another virtual machine in the cloud and start with a time to live in your packets with a value of 0, and try to connect. If you don't connect, the TTL wasn't high enough. Then you increase by 1, try again, and repeat until the connection is successful. And then you know the hops between you and the potential victim. So side channels, in principle, show that you cannot hide the physical or the reality that's in the cloud, and you can find out something about the internal infrastructure. This might be good for an attacker who might find out where he's residing in relation to a virtual machine. But you can also use such side channels as a customer to check whether the cloud is delivering the promise, what is promised in the contract. So assume the cloud is promising you hardware redundancy when storing your files. And a lot of providers, especially if they are a lot larger than you as an ordinary customer, they won't let you look into their facilities. So you have to gain this information somewhere else. And one idea is to use this kind of side channels where you send a challenge to the cloud and wait for the response. The idea behind it is if there's hardware redundancy and you ask for 3 blocks that are stored on the hardware drives, that fetching them is faster when there is some kind of redundancy, and that fetching, because they can be fetched in parallel, and if there's just one drive, it will be slower. And if you measure that, you will have 2 cases. The upper case is more or less the case when you have just one hard drive and all the blocks are stored on the same hard drive. So it takes longer because you have the latency to send the challenge there. Then you have 3 times reading the blocks, 1, 2, 3, and afterwards you have the network latency back. And you will go beyond the threshold, and so you as a customer know that actually there's no hardware redundancy. In the other case, where we have 3 drives, which is the lower case, reading is done in parallel, and so the time for reading just adds a single time to the total time span for the challenge, and you stay below the threshold. Obviously, the challenge thereby lies in modeling this threshold, but in principle it's feasible, and it's quite a meaningful way to check whether your provider is conform with your contract. But coming back to data, this means also that we get internal data about clouds that we wouldn't have before as a security researcher. That's one part of large internet infrastructures, but also the internet as a whole is a challenge if you need information. So basically it's an experiment that escaped the lab, and so you don't know what's really on the internet. And if you want to know, for example, how many servers are there for amplification attacks, you just have one alternative, and it is to measure how many are out there. So we had local setup to evaluate our attacks. Now, if we have large internet infrastructures, we have to gain information by measuring and get our data there. And this is now elevated to a next level when we go to cyber-physical systems, or in my case, because I'm an electrical engineer by training, the power grid. So if we want to evaluate attacks against such an infrastructure like the power grid, we will be hardly allowed to test on the real systems for very obvious reasons. First, there are a couple of millions of people connected to the power grid who will fairly be unhappy with what's happening there. Second, it's really expensive and painful to restore its functionality, so actually it's not a good system. So 1 year ago, we developed some attacks and we wanted to evaluate them, and so we had to find another solution. And what we have to do then is to form a test bed and evaluate our attacks. The problem is, however, how do we get a test bed? You can either use a finished test bed that should be somewhere around, or you have to create it yourself. And this is where the challenge starts. So the first thing you might want to have about the power grid is the frequency. So the frequency in the power grid is an interesting parameter for the health of the system. And in principle, it's measurable on every power plug that's installed somewhere in Europe. So you can measure it at a private apartment in Portugal or in Turkey or somewhere in between, but you don't find historic data of that. So the only chance that you have is to measure it, but then you have to start now, and you will have long-term data in maybe 2 years. If you want to analyze some past incident, you won't get the data, because as a security researcher, we just don't receive them from the facilities that have the data, although in principle, they are publicly available. That's challenge 1. Challenge 2 is you might want to make a model of all transmission lines. They are not that high number because the really high voltage transmission lines are maybe a couple of tens in Austria, a couple of hundreds on the whole continent. And you even receive all the information from the Austrian power grid with details on where they start, where they end, some electrical parameters like voltage, length, resistance, and so on. The problem is, however, when you start to process them automatically, it's a PDF, and there's no way to, process that automatically. The only chance was to get a student and make him let him do the work manually, and cross-check every value whether it didn't change while copying. This was rather the easy part. If you want to have all the transmission lines of Europe, you will have to go through the homepages or mail all the transmission lines provider. And it's good to speak all languages of Europe, because they are typically in the national language and are not very fond of speaking in English, and you won't receive the information in all countries. So that's not a good part. This is another alternative that we checked. It's eventual is the association which connects all the transmission grid providers, like in Austria, the Austrian power grid, on a European level. And they should have all the information, and they even visualize it in their fancy map. But still, you don't receive the information from there. The only chance is to reverse engineer the map that's here. But you won't receive the full model. You can ask for the full model, but then you have to sign a non-disclosure agreement, which is not what we want, because we as a researcher live from publication. So if you're not allowed to publish, it doesn't have a worth for us, although it's still interesting, of course. So that's also not the solution that we were looking for. And finally, the last challenge that we had were finding something that is called load profiles, in principle, that are really sophisticated statistical models about your energy consumption. This, for example, is the model of an typical Austrian household spending energy, and it's dependent on the time of the day of the week, the season, and so on. And they are used for forecasting electrical energy, so that the power provider can sell and buy the right amount of power. And these models are really sophisticated. So we have households. These are mobile cell towers that are standing around. They consume the same amount of energy over the whole day. Or they even have models for street lighting. There was even a model for hairdressers in Austria, because they are usually closed on Monday. So they are really sophisticated models, and we needed them for our research as well. And you get them on the homepage of the Austrian Power and Clearing Settlement. So it's mainly a more or less public agency. But the problem is, it's an MDB format. MDB, for those not aware of it, it's Microsoft Access. And personally, I'm using Linux, so I didn't have any chance to use it. I have to admit, it changed now, so you get an Excel file right now, and also comma-separated files. But this is just a real novelty of the last year. So this is more or less the whole way that we went through when doing our work. And in the end, I have to admit, we got our model, and we could do our research and could evaluate our attack, and were able to say, well, it's feasible. I don't want to go into the details of the attack because this is not the topic of the talk. But the problem that we have when we are evaluating our attacks in that way, that our research results are not of the quality that they could be. Because the information is out there, but we cannot exit this information. So if we publish such work, then the expert of the power grid community, for example, tell us that our data is not accurate enough. And we didn't include that and didn't include that. But the problem is they won't give us the data. So this is really the problem that remains, and a problem that we face when working together with other subfields in order to evaluate our attacks. Good. So I was now in a totally different topic, as I assume you're all more or less developers, as the conference name indicates. So what are the conclusions for you? So it's not only artificial intelligence that needs data, it's also us researchers. And the problem is that we have usually a lot less money than you. So getting the adequate data is really, really a challenge. And in the examples I brought before, I didn't talk about privacy protection or some data protection mechanism, because that is just some structural data, but it becomes even more complicated with such data. And we need this data because the more important the system is and the less we have a parallel setup where the attacks can be evaluated, we need this data to have such test sets. Whether we get the data as a plain data or the finished model, both is okay for us. So that are the conclusions for you. And on a higher level, because I'm dealing with security all the time, it's please do security first and maybe make security great for the first time ever in history. So thank you.
Excellent. We're almost there. We have questions. Excellent. You can come to my side of the stage as well. Regarding Austrian transmission lines, why not make character pattern recognition on the PDF? What?
Well, the mean answer would be students are cheaper. And just this one was, so the list was rather short, so instead of programming it, it might be okay to do it manually, but of course this is a meaningful way of performing this task when the list is longer.
Cool. Is there a Git repo to access MDB files called MDB tools? There is a Git repo to, okay, that's not a question. Do you apply some...
Thank you, we managed it now, otherwise.
Do you apply some special processes when you're hiring? How do you make sure you hire the good hackers?
This is a question we're also dealing internally with. On the one thing, it's reputation. On the other hand, it's gut feeling. And you typically check something in the background. So people working for us typically don't drive very expensive cars, and we would be very astonished if they would do so. So we more or less check on the outside, but we cannot guarantee for it. Yeah. But on the other side, we are publishing our results anyway. So the advantage working for us wouldn't be that high for an attacker. I hope I explained that in an understandable way.
Okay. Who's the customer of your research? Maybe the customer has that data.
State. So we're mainly funded by a funding agency like the FFG or the FWF. For our research department, we also have a commercial department in our company. There, large other companies hire us to do penetration tests, and we're not allowed to disclose their names, but it's more or less a who is who of the Austrian large companies.
And the data is most of the time in formats that might not be portable as well.
Sorry?
The data is not in formats where it's accessible readily. When I worked with the UK government, a lot of it was in spreadsheets across different servers. It was like they asked us to get to the data, but then it was basically in formats that we couldn't use them or reuse them as well.
Yeah.
Why can't you simulate the cloud with Docker and Raspberry PIs?
You can simulate it, but to get a good simulation, you have the same problem as when you can simulate it, and like you can create a test bed, but the problem is that you have to know what you're simulating, and therefore you have to spy on the cloud first, because you don't have how to simulate a cloud. Yeah, I mean you can refer to basic setups, or default setups, which represent some default ways of how clouds are installed. But still we have to find the information of how a cloud is built in reality. If we just have a setup, then we just create some kind of setup, and we test our attack there. Then the response is, as in the power grid thing, yeah, the attack works there, but our cloud looks totally different. So it's not the attack is not feasible there.
And for good penetration testing, you also take the hardware into consideration and the network facilities. So you're not necessarily just look at making your own rig with data, because a lot of times the routers is a good attack point.
Yeah, yeah.
Are you saying that servers are safer now because they run in the cloud? Kind of a loaded question, isn't it?
The answer would be it depends. Yeah, and it's yes and no, and it depends on the certain characteristics. And I also have changed my mind on that. So at the beginning, I was rather for servers not in the cloud, as you lose some control when pushing something in the cloud. But on the other hand, if you think about the IT system of your doctor, that is in most cases one server, and the backup is a USB drive, which could be easily taken away or stolen if you just make some nice jokes with the assistants at the entrance. The cloud solution might be more secure. So my answer is it depends.
So there's the easily keeping it up to date. So you're not going to likely run it with Windows 2000 or Windows XP servers in cloud providers, but at the same time, it's opaque. You don't know what's running. So you think more insight into what the hardware of your cloud provider gives you might be interesting for people. Or again, it assumes a knowledge of the end user that they probably don't need to have.
It's both ways, I would say. Yeah.
You could say it depends.
Yeah, it depends. That's the only real answer I can give. So, like I said, for example, you will never reach the uptimes of a cloud if you have such an easy setup at a small office. But on the other side, you lose control. But if you weren't able to deal with the control, you won't lose anything. Yeah. So there's even less chance that you do something wrong.
I love that we're getting in like sci-fi space here. Like, if you're backed by the government, how do we know you are not spying on other governments? I don't think you have to answer that. Or are you allowed to answer that, is the question. If you're not, then we know.
Well, I mean, I'm Austrian citizen, so I think that's enough of an answer. Yeah. So.
It is a weird thing how like the computer geeks are like, we hate working for governments, but at the same time we complain about governments not being up to date.
Yeah.
It's not helping the cause, is it?
It's not helping the cause, and yeah, at the moment I have to admit that we don't deal with any attacks against foreign countries, because our institution wouldn't be the perfect way of doing it. We're a research institute that is quite open to students and other people, so we're more or less talking publicly about almost all that's going on. So I think transparency is the only thing we have.
Excellent. What's the scariest thing, I think that means, you discovered by analyzing our grid?
Well, you can take down the whole European grid, and the European grid spans more or less from Portugal over the whole continent of Europe down to Turkey by a botnet of roughly 10 million, with 10 million infections of IoT devices. I mean, that's nothing that a script kiddie does in an afternoon, but instead of doing war against a foreign country, I would prefer it.
I worked...
and the problem is not that there's a blackout afterwards. The problem is to restart all the power plants afterwards, because power plants need electrical power to come up. So we need some power plants that have something that's called black start capability, and there are just some of them, so you have to start them first and afterwards the other one, and then you have to hope that the system is in balance, otherwise it shuts down again. So bringing it up will cost 2 or 3 weeks, if we're lucky.
So let's buy candles and meat that cannot go bad and prepare for that. Thank you very much.
Yeah, you're welcome.
Last break.